Hi everybody, my name is Attila Toth. I'm a developer advocate with ScyllaDB. In today's video, I want to talk about data modeling basics for feature stores, more specifically for online feature stores. So before I start with the practical example, I quickly want to show you this diagram to kind of explain why it's important to think about data modeling in the context of feature stores. So if you're building a feature store, you have probably seen diagrams like this, and your specific architecture might look different, but the basic idea is that you have two separate databases within at least two separate databases inside your feature store architecture. You have an online feature store and offline feature store, and you have very different requirements for each of these databases. In the case of an online feature store, you probably need high performance, low latency. As an example, you might require less than 5 millisecond P99 latency. And in order to achieve this kind of performance, you do need to think about data modeling, and you have to make sure that your data modeling is right. Otherwise, it will be hard to achieve this kind of performance at a larger scale. All right, so that is why we are talking about data modeling. So now let's get back to the example. I'm going to show you one of our sample applications. It's a used car price prediction application. So basically it helps you predict the price of a used car based on its properties like year, model, engine size, other parameters. So what I have done so far is spin up a new ScyllaDB cluster just using Docker. You can also use ScyllaDB Cloud, and I use SQL/SH to connect to the cluster. So what I want to explain here is kind of a thought process behind creating a schema for the feature store, for a feature store application. Here we have an example where we create a key space, we just call it feature store, and then we have the tables defined here for the feature store. So this is kind of the main table where we store the actual values that are needed for the machine learning model. Because what you would do in practice is, let's say you have a machine learning model, you want to get it to production, you want to get it in front of end users, you need an online feature store, because that is what is going to give you the scalability, the performance needed, so the end user can actually benefit from your machine learning model. And you would have a table something like this. We have car ID, we have feature name, feature value as the columns. And this kind of table design is scalable because you will be able to add or remove features in the future if you need to. So for example, let's say transmission is a feature right now, but in the future you realize that it's actually a feature that you don't want to include in your process, so you want to drop it. And because you have feature name as a column, you can just easily remove that feature from your table without needing to alter the schema, which can be complicated. And then the next thing, which is important as well, is the primary key. So the primary key will basically tell you what queries will be really performant, what queries will scale really well, and what queries will not work that well. So for example, here we have car ID and feature name as the primary key. And what that means in a ScyllaDB context is that car ID is the partitioning key. So basically your data is partitioned across the cluster using the car ID column. Now, feature name is going to be the clustering key. And what that means is that ScyllaDB will sort your data within each partition according to the feature name column. And what that means in practice is that now you can run queries where you filter by the car ID column, and you can run queries where you filter by the car ID column and the feature name column. So in practice, your feature store application will be able to query all the features for one specific car, which is probably the most popular use case because that is what you need to pass onto the machine learning model. The machine learning model will need all the features for one specific car. But if you have a use case where you also need just one specific feature for some reason, this data model will allow you to do that as well. So that is kind of the main table that we have. And then we also have another table for the application, but it just stores the row parameters of the car. As far as the feature store architecture itself, it's not super important. So let's create this schema, and then let's run the application. So now I'm going to create a new virtual environment. I'm going to install the dependencies, which in our case, scikit-learn, Scylla driver, which is going to be needed if you're using ScyllaDB in Python. And then we are using Streamlit for the user interface, so I need Streamlit as well. So once the dependencies are installed, I'm going to go ahead and run the Streamlit application and then open the app tab. This is the same application that we're working with. Let me move my cam over here. So we have all these parameters on the left for the car. I already talked about this in a previous video, so I'm not going to explain the same application user interface. But basically, once you hit submit, the system will, or the application will query ScyllaDB using the using this schema that we defined. And then, as you can see here, like we are actually querying this car ID in this example. And then these are the features for the car. As you can see, we have a lot of different feature names. We have 37 different features, but that's fine. And then we have the prediction at the bottom. And the prediction is created based on these feature values. So that's the example. If you want to get this example and run it on your own machine, you can absolutely do it. We provide a link in the description. Everything is on GitHub. You can use Docker, or you can also use ScyllaDB Cloud if that's easier for you. So that's all I wanted to share today. Thank you, and see you in the next one.